Welcome back to our SQL learning session. Today we'll be learning about joining tables from Database for Developers. In this lesson, we have 9 sections. We'll go through each of them. We'll start with introduction. You can combine rows from two tables with a join. This tutorial explains the join method using these two tables. They are select from toys, select from bricks. Let's run this and let's see what we get. Let me run the prerequisite SQL before we do that. has been ran. Let's run this again. And we have two tables with 3 rows each. Second is join syntax. Oracle versus ANSI. Oracle database has two syntaxes joining tables. The proprietary Oracle method and ANSI method standard way. Oracle syntax joining tables is in a where clause. ANSI style uses separate join clause. This tutorial will explain both methods. We recommend using ANSI syntax. This clearly separates join and filter clauses. This can make your query easier to read, particularly with other joins. But which approach you use is largely a matter of personal preference. Whatever you do, choose one style and stick with it. Third section, cross joins. A cross join returns every row from first table matched with every row in second table. This is always return the Cartesian product between two tables rows, that is, number of rows in first table times the number of rows in second table. Rows in bricks, both rows have 3 rows, so cross joining them will return 3 into 3 is 9 rows. To cross join tables using Oracle syntax, simply list tables in a from clause. This is a cross join where you will get 9 rows. 9 rows selected. Now let's try ANSI, where you select from toys, cross join bricks, and you get the same result. It is rare you usually use cross-join in your code. If you need to use cross-join, often it is a sign something is wrong with your data model. If you do need a cross-join, ANSI syntax makes it clear this is your intent. Note, and not that you forgot to your join clause. Fourth section is inner join. Inner join links two tables. It compares values in one or more columns from each. It only returns rows which match the join condition in both tables. Simply join checks if the values in a column from one table equal the values in a column from other table. For example, you can join toys and bricks where toy ID equals to brick ID. Only the IDs 2 and 3 2 and 3 are in both tables. There is only one row in each value in each table, so this returns 2 rows. Let's do this. This SQL joins using SQL Oracle syntax joins two tables and returns 2 rows where toe ID is equal to brick ID. Now let's do ANSI way. In this, it select from toes inner join bricks where toe ID equal to brick ID. An inner join can return any number of rows from 0 to cards in product two tables. If you join a column that has repeated values, you will get many copies of matching rows in a join table. For example, there are 2 blue bricks The toy categories is blue, so joining the table on a color returns two copies of row for categories. Let's run this. Can you guess what this will return? This should return the 4 rows or 3 rows. The toy color is blue and brick color is blue. Since brick has two blue with a different shape, cube and pyramid, categories is repeating twice. Note that keyword inner is optional. You can also join on inequalities. For example, to return all rows that have different color, you can write this. This join will return all the rows where toy color is not equal to brick color. Note, there is no pink bricks. So this is a copy of pink toys for each row. So miss appears 3 times. Since we cannot find pink bricks, it returns, it is joined against blue, green and blue. And for rest, it is joining with the one that is not equal to blue. Green is to blue, green is equal to blue. Now let's try it. Yeah, we need to complete the query by inner joining toys and bricks where toy ID is greater than brick ID. Where we will join with inequality here. Toy ID is greater than brick ID. On it will join those rows where toy ID is greater than brick ID. And that's only one row. Toy ID, 3 baby towel green, 2 blue cube. And this is what we need. Number 6. Outer join. Can you tell me what outer join is? An outer join returns all rows from one table along with the matching rows from other table. Rows without a matching entry in outer table have null for the columns. An outer join can either be left or right. Brushing defines which side of join database preserves rows for. Following left join, toys and bricks in their IDs. Two is in left side of join, so the other returns all its rows. We also get rows from bricks which have same ID as these. Now let's run this using ANSI. Here, this is the ANSI format. Toy is on left side and brick is on right side. This query should return all the rows from toys and all the bricks where toy ID is equal to brick ID. And exactly it does. Now, we want to return all the rows from bricks and only those rows from toys that have two IDs equal to brick ID. There is two ways to do this. One is you can change the left to right. If you do this, then all the rows from bricks will be returned with matching toys. Another way to do it is we can just switch the places in this SQL such that toy is in place of bricks while bricks is in place of toys, and keep the left same, and it should give us the same result. Here, so what's happening here? If we do this, then it should give the same result. Let me do this. It should give the same result here. An outer join will always return all the rows from the preserved table. So the number of rows written varies from the size of the preserved table to the Cartesian product tables. Now let's do an exercise here, just for sake of curiosity. I'm going to run this. I'm going to run this SQL, and you get two sets of table. Now, what if we join on the toy color? What would happen? Let's join on the toy color between bricks and toys. Let's do left join on toy color. Brick color. And what we should get? Can you guess what the result will be? It will return all the rows from bricks. That's for sure. Well, let's do this. Let's do toys and bricks. This will return all the rows from bricks, toys. But if we do the left join on bricks, what will happen? There will be a table we'll get, but how many rows we should get? Can you guess? Let's run this and see what we'll get. Here we are getting 4 rows. How is it possible? Cartesian is being repeated twice. There is a Cartesian product going on between toys and bricks because there are 2 bricks in the right side of the join, and because of that the Cartesian is being repeated twice. So this is a Cartesian product going on, and this is very powerful. This is a very powerful example that when you run this thing, you know that even in a left join there's a Cartesian product within the equality. Since there are 2 blue in the right hand side of the join, of the left join, and on the left join, even though the only blue row is be repeated twice to match the number of blue varieties on the right side. So this is really important to note. Let me take a screenshot of this so that we can use it for future reference. And just paste it here. Now, moving on to 7, the filtering joins. You can filter rows returned by join in your where class. For example, the following join table on your IDs. Then filter the result to only show the combination that have green bricks. Now let's run the ANSI query of this for this, where I'm going to do inner join for toys and bricks on toy ID and brick ID, and I'll be setting only brick ID is equal to color. Let's run this. And there's only one row where brick color is equal to green. But you must be very careful when doing where clause in outer join. Say you want to return all the toy rows, any brick row with the matching IDs, and a color is green. You expect the result to include 3 rows from toys but brick details for brick ID 3, such as this. When we do the where clause. Now let's run this query and see what we get. We have a query where we have toy on the left side of the join and brick on the right side of the join. For left join, it is join on toy ID and brick ID, and we are putting a condition on the right side of the join, the unpreserved, not preserved side of the join, and toy is green. What would this will return? Can you guess? Let me run this. It returns only one row. Why is that? Where are these null values? This is a problem we are trying to show you and trying to fix it. To fix this, you must place the filtering criteria for the outer table in a join clause, not in a where clause. That's the mistake we made. Now, let's put this in the where clause. Let's put this in the where in the join clause instead of where clause, and we get the 3 rows where some values are null. Now let's do an exercise. Let's complete query below to return all rows from bricks and any rows in toys with toy ID equal to brick ID and toy color is blue. Let's do this. Where left join on toy ID equal to brick ID, where toy color blue. And if you do this, what will return? It will return only one row, or it will not return the right result. Now let's do AND here and see what we get. It returns a row, but where are the null values here? We don't see any null values. Let's do this. Let's run this now. Now you see the difference. In the first query returns the output with only one row, but second query, when you put the toy color is equal to blue in the join condition, it returns 3 rows with null rows. And this is exactly what we're looking for. Section 9, full outer join. And this is the last section. Sometimes you may want to join two tables to find matching rows, but also include any unmatched rows from both tables. This is called double outer join. This is known as a full outer join. Here's the ANSI syntax for this. We have a two rows, Trojan bricks, and we are doing full outer join on toe ID equal to brick ID. This table returns all the rows from both tables which are present in both based upon the condition, and all the unmatching rows from right table and all unmatching from left table on both sides. In this way, let's run this then. Here we get four rows. First row, two rows are present in both tables, while the third row is present only on the right table, and the fourth row is present only on the left table. So this way we can do full outer join. In the end, let me quickly summarize what we learned today. We learned about joining tables. We started with introduction. We talked about Oracle over ANSI syntax. We talked about cross join, inner join, and we talked about outer joins. And there are two kind of outer join. One is the left outer join and one is right outer join. We talked about filtering join and some caveats where when you put the filters in the where clause versus filtering in the join itself. And lastly, we talked about full outer joins and the result it returns when you do full outer join. So that's all for today. I'll see you next learning session. Thank you so much.